MIT, the university, proposed a nuclear power plant, which is floating. So it is a kind of ocean plant or offshore structure, in other words. But this is just a proposal saying that this is a computer graphics image rather than real physical picture. But it is a good idea, right? Because of the plenty of water, and when something is wrong, then they can put that hot nuclear core into the water, as a safe secondary safe measure. And this one shows you the wind power, renewable energy. But as you see that as time go on, from 1980 to up to 2010, the size is increasing, and also the power production amount is increasing. Do you know, anybody knows that the heater, electrical heater, left-hand side picture, how large of that electricity is required to maintain this electric heater? Anybody can say in terms of kilowatt numbers? How many kilowatts used for your electric heaters? No, nobody can answer. Anyway, the small one, the diameter was 50 meters in 1980. They produce 50 kilowatts of electricity when they are in regular, steady operation. And then it comes to the 2010 recent one. It goes up to 10 megawatt, right? 10 megawatt. And the size or diameter of the turbine blade is 180 meters. Right? Can you imagine how tall is this in comparing to a building? Do you know how tall is a large building? So can you say that how many floors corresponding to 180 meters? Anybody? Answer? You can say that, let's assume that one floor height of a building.
Maybe around 25 floors.
Please again, say again, please. Say again. I did not hear you. How many floors?
Around 25, I guess.
25, right. Around, yes. If you assume that one floor height can be, say, 5 meters altogether, including structural members and pipings and cables, then it can be 36 floors, right? 36 floors. So 36 floor is very high building, right? And then in addition to blade diameter, there is also more height by this strut or column at the bottom size. It can be additional, say, 80 meters something, right? So altogether it can be, height can be 200 or 60. That may be a 50 floor building. So very big, very big. Okay? That is not staying still. It is rotating blade. So high-rise building of about 50 floors height, and they are rotating once a second. That is a very big structure. And they are already in the field now. All right, and then, so the trend of wind energy system, it was started in 1980s, and they are started as a land fixed system at this bottom, left-hand side. And then nowadays, more popular is ocean bottom fixed. The same as land fixed one, but it goes to the shallow water of ocean. Why? Because of the wind quality and because of the land cost. And also recently, there are many complaints coming from people living, sleeping around the wind post. The noise is coming from the wind power rotation. So that people are pushing this system toward the ocean because of the land size, because of the noise. Then, so the right-hand side, it is going to be deep water, far away from the land. So there are advantage and disadvantage written in on the bottom side, and so that you can see the red colored ones from the land fixed, the noise, and the site limitation, the area. And but in floating side, the problem is the cost, the economy, because it is floating, is far away, so you need to have a more structure, more to be a floating body of larger size. So once again, the economy is problem here because of the cost. So anyway, the trend is going far away and larger. Now it is a mobile harbor. It was a very famous project inside KAIST around 10 years ago. At the time, the president of KAIST was coming from MIT. His name was Sonam-pyo at the time. He propelled one of this project. And the A1 means a type of mobile harbor. We had another one, or the other one. And 2050 is the size of the mobile harbor, and TEU is a unit of counting the containers. So it means the ship and also the crane, floating crane, you can say. But this is the mobile harbor, we call A1, the floating crane. It is the same as mobile harbor A1. And they can handle up to 250 boxes of containers. Question? Okay. So this is a picture of container and container trucks. You can see also in the street. And once again, the TU is a short name of 20 equivalent unit. That means the length of the container is 20 feet. So the basic unit for counting a container box is a 20-foot length container box. So from the picture, the length is toward the ship length. You can see from the side that around the ratio, right? And from this figure, I can say this container looks like a 40-foot container. So it's a doubling the size of 20-foot container of previous slide. So you can say this one 40-foot container can be counted as 2 TEU, right? So that is the way the counting the or measuring the size of the container ship. TEU is important. Terminology you need to memorize. And aircraft carrier is well known to everybody. It's designed for deploying aircraft for air forces for fighting, acting as a seagoing airbase. So you can say this ship is an airbase, but airbase usually located in the land, but this one is can say ocean-based airbase. And there are many airplanes here above the deck, but also there is a elevator which can carry aircraft, jet fighter inside the ship, below the deck, so that there are more airplanes inside the ship. The largest type of aircraft carrier is a Nimitz class, because the length is more than 300 meters, and weight is 10 or 100,000 tons, and speed is 30 knots, and engine is used by nuclear power plant, and horsepower is 260,000 horsepower, and it carries 90 aircraft. It's a big number, right? Here on the deck, we can count how many aircraft here? 10, 20, 30, 40, less than 50 is of the deck. So about 40 aircraft is below the deck in storage using the elevator. All right, question? Power range. I asked you when I show you wind power energy, the electricity required for the stove, electrical heater, the answer was 2.2 kilowatt. That is a typical size of electricity. So you may say that for this smallest 1980 smallest wind power system can operate about 20 electrical heater like this at home, right? So power ranges, horsepower is about 1 horsepower is 750 watt, and 1 kilowatt for electrical heater in a home. At the bottom there is a 2.2, but the range is about same order, So horsepower is about 1 kilowatt. Right? So horsepower is coming from power of the horse, the animal, is about 1 kilowatt. Right? About same order. And largest wind power system, as I showed you in this picture, was 10 megawatt, right? But here it is saying 6 megawatt. So I should modify this as 10. That's better to understand, right? And the gigawatt means 1,000 megawatt for a commercial nuclear power plant. Is around that order of size. In Korea, recent construction of nuclear power plant is popular of size of 1.4 gigawatt. So you can imagine that 1,000 pieces of 10 megawatt wind power is needed to replace one nuclear power plant. 10 multiply by 1,000 can be, no, sorry, 100 of 10, right? 100 of 10. So we need 100 of 10 megawatt wind power systems at one site. It can be corresponding to one nuclear power plant. 100, yes. Okay. Question?
Sir, I have
Go ahead.
I had a question about the environmental safety of having like wind power plants and nuclear power plants in the ocean. Like, do you consider which one do you consider to be safer?
What's safe? That's a tough question to me. How do you think then? What is the answer?
I think nuclear is safer, but then again, there are a lot of stigma behind it.
There are many debates on this, right? So it's not easy to answer this. But usually wind power system, there are not so much pollution coming out. One problem is noise, right, coming from wind power system, and some disturbance around the location. But also people are saying that because of that structure, there are more fishes are coming. Very similar to island. Near the island, there are more fishes comparing to just vacant ocean, deep water. The fishes are there, but they are not many. But near the island, there are more fishes coming. So it's better than, but anyway, to construct the 100 of wind power system, you also need to use energy. So it's not easy. You need to count all of them together. Also, nuclear power plant is very fatal once it has a problem, but the probability is very low. So I don't know, how can you compare this together? Very low probability, but it's a high level of fatality. Yeah, somebody want to discuss about this?
Yeah, what about I think the stigma, as Adiba said, about nuclear power plant is mainly based from the catastrophes we have faced recently in Japan and also in I think Ukraine.
Right.
What about the design we just looked at? The MIT design, like where they have a nuclear power plant in the middle of the ocean. So in case any disaster like the previous one happens, I think there is not going to be that much casualty and people are going to be safer.
Right.
Doesn't that make nuclear power plants like the best form of energy source?
So there are nuclear. Oh, one student is coming from nuclear in this department. Oh, double major. Who was that? Who was Kim Gi-yeon? Okay, he knows much better than me, probably. But the nuclear engineers nowadays, they are trying to design a even more safer next generation nuclear power plant. And there are many ideas. Also, the president of Microsoft, what is his name? He is also support that kind of idea, right? So he create a new company to make a new design for nuclear power plant. One of our idea is because the Fukushima accident was due to electricity is cut off because to the motor pump, which can be used to cool down the reactor. Because of the accident, the electricity go to the motor pump was cut off. no electricity to the motor pump, so that coolant system is not working. That is the main reason for explosion. So that one idea that the next generation safer nuclear power plant is, they are saying non-active. So they are saying passive cooling system. Even though there is no motor pump is working, there is another way to have a cooling down, passive, not active cooling system. That is one other idea. But there are so many different ideas to make more safe, even more safer nuclear power plant. So I don't have an answer. Indian, you can say something more. You need to turn on microphone again.
Yes.
Okay.
Well, yes, that is almost, that is, I think that is a correct that the professor said, and to add on, people are trying to use other material except of water, because water can divide into hydrogen and make an explosion. So they try to cool down the nuclear reactor without water, such as carbon dioxide or helium. And I think they might can make a better nuclear reactor, not VDER or BWR, I guess.
See, the material, the coolant can be also improved. Okay. Any more questions? No.